In the previous class, we have studied regarding the one of the optical instrument, that is regarding the microscope, simple microscope and compound microscope. Just only to see the magnified image of the microscopic, okay, microscopic things. So we will use the simple microscope. So next, in order to see the detailed of the organisms, okay, parts, for that we are shifting to the compound microscope. Okay. So next concept is regarding the one of the important optical instrument, that is regarding the telescope. Here telescope can be also classified into two types, that is depending upon the phenomena, that is refraction and reflection. So refracting type telescope and one more is reflecting type telescope. Okay. So telescope mainly used to see the distant objects. Here the refracting type telescope, refracting means lens, has been used. Refracting type telescope, it is two types, astronomical telescope and the terrestrial telescope. Whereas reflecting type telescope is Cascadian telescope and the Newtonian telescope. Okay. So let's see regarding the refracting type telescope. Okay. It is the refracting telescope. The diagram which I have drawn here, astronomical telescope. Okay. So here this astronomical telescope is used to see the far objects such as stars and celestial objects. Okay. One more I have said, that is terrestrial telescope, that is used to see the objects present on the earth, that is any, for example, object present on the peak of the any mountain, or objects present on the tree, okay, etc. Let's see regarding the astronomical telescope. Astronomical telescope also consists of two lenses. One acts as the objective lens and one more acts as the eyepiece. One is objective and one more is eyepiece. Okay. So here the final image nature which we obtain from the telescope, that is it will be virtual and invert in the form, but we are not going to consider the nature, that is whether it is, since it is far object, for us it will appear like a appear in the round shape only. Okay. So here the light rays coming for the infinite distance, that is from the stars, okay, that is distant objects, which passes through the objective. Okay. By doing certain adjustments, it finally the image of the first lens is observed somewhere at the position where this distance will be acted as a focal length. This one distance is the focal length of the objective and this distance will be in the focal length of the eyepiece. So if our object is at infinite distance, image will be at principal focus, or so that will be nothing but our focal length. So this distance is the focal length of the objective. Similarly, so from here only focal length of the eyepiece starts. If once again our object is on the focal length, the image will be shifted to the infinite distance. Okay. So here the main aim of the telescope to see the far object very clearly. Okay. So drawback arises in order to see the far distant objects very clearly. resolving power. Resolving power means we cannot see two objects distinguished. We cannot clearly differentiate two stars which is lying closely to each other. If there are two stars, okay, with certain distance, okay, in this case for us it will appear like a one single star. Okay, we cannot resolve that. Okay, we cannot distinct that. That is nothing but resolving power. So this is the demerit of this. So one thing is, in order to get the high light gathering capacity and high resolving power, we should increase the size of this aperture. As we go on increase the aperture size, the focal length varies and it is will be very difficult to handle the instrument. So with the help of beam only we should handle this lens, okay, and cost of that lens will be high. Okay, next, so these are some demerits. So in modern days, or they have shifted, instead of that they have replaced the refracting instrument, that is instead of lens they have shifted to the mirror. Okay, so here our objective is a primary concave mirror. Okay, our objective is replaced by a primary concave mirror and there will be a eyepiece through which we can see the distant objects. Okay, so here when we can rotate this, okay, so when a light ray passes through this tube, through this, what happens, it get incident on this concave mirror. Okay, light ray get incident on the concave mirror. Which phenomenon occurs? Okay, reflection or refraction. In case of lens, refraction phenomenon occurs, whereas in case of reflection, okay, so whereas in case of mirror, reflection phenomenon occurs. So it has the name reflecting type telescope and refracting type telescope. So when the light ray get incident on this, one more arrangement is there. There is one more mirror, that is secondary mirror. Secondary mirror, it is the primary we have to increase the size, aperture size of this objective lens. So demerit arise, that is aberration and distortion occurs. Aberration is nothing but we cannot focus entire color at a particular single point and the image which we obtain, it will be blurred. And one more thing is that we cannot clearly distinguish the two nearly lying objects. So which will be overcome by the refracting type telescope. Okay, this concept is regarding the telescope. Okay, I will solve some problems. That is on combination of two lenses when it is in contact, also using the refractive index of the prism. Okay. Two lenses of focal length. Okay. One is 0.2 meter and one more is 0.3 meter are kept in contact, are kept in contact. So find out the focal length of the combination and also calculate the powers of the individual lenses that of the combination. What you have to find out? Equivalent focal length. Okay, equivalent focal length when two lenses are in combination, and also you have to find out the individual power of the lens and also the equivalent power. Okay, what is the formula? We know that when two lenses are in contact, 1 by f is equal to what? 1 by f is equal to 1 by f1 plus 1 by f2. So f1 I will take it as 0.20, f2 as 0.30. If I simplify, directly I will get 0.12 meter. Okay. So next f1 is what? 0.20, but v1 is equal to what? 1 by f1, which is nothing but 5 diopter. That's the SI unit of the power. Okay. Next, f2 I have taken as 0.30 meter. That is p2 is equal to what? 1 by f2. If I substitute and simplify, I will get 3.33 diopter. Okay, equivalent value. So which is nothing but p is equal to 1 by f. P equivalent value is nothing but reciprocal of this. What's that? I will get the value 8.33 diameter, or you can add this also. You will get 8.33 diameter. Okay. So next, sine of a plus b by 2 divided by sine a by 2. Okay, let's substitute. A is 60 degree, d is 40 degree. 60 plus 40 is 100. Sine of 100 by 2, that is sine of 3 degree. Okay. Next, sine a by 2. Sine a by 2 means sine 60 by 2 is sine 30 degree. Sine 30 is 0.5. Sine 50 is, use the log table. So I'll get the value, that is 0.76 divided by 0.5. The refractive index of that prism is how much? 1.52. Refractive index of the prism is 1.52. Okay. Next, I. A plus b by 2. What about A? 60 plus 40 by 2. 100 by 2. How much I will get? Angle of incidence value is 50 degree. Or directly you can write here also. Okay. Okay, let's one more problem. A prism is made of glass of refractive index of unknown refractive index. Okay. Let it be N1. A parallel beam of light is incident on one of the face of the prism. Okay. A parallel beam of light is incident on the one of the face of the prism. By rotating the prism, okay, the prism has been rotated. The minimum angle of deviation is measured to be 40 degree. The minimum angle of deviation is measured to be how much? 40 degree. Next, what is the refractive index of the prism? Okay, what is the refractive index of the prism? Angle of the prism is given as 60 degree. Okay. Next, what I have said, the same prism has been immersed in an outer. The same prism has been immersed in an outer of refractive index 1.33. Okay. Same prism has been immersed in a refractive index of water, that is 1.33. Okay. So here, what you have to find out? In this case, you have to find out the deviation value. Okay. So initially, one general refractive index value is given. Okay. For that, use the formula n is equal to sine of a plus b by 2 divided by sine of a by 2. Okay. Here both the case 60 and 40 degree. 60 is the angle of the prism. Okay. 60 is the angle of the prism. 40 degree is the deviation of the prism when it has been placed in the air medium. Okay. So what I have solved just now, I will get the value. Similar case 1.52. Okay. Exactly what I have done few minutes before. Okay. Next, what happened? Same prism has been immersed in a water. Okay. So same prism has been placed in a water of refractive index is how much? 1.33. Okay. 1.33. So here, what you have to find out? Angle of the prism will be fixed. That is, angle of the prism will be 60 degree. Deviation value changes. The deviation value changes. So, refractive index of water, refractive index of the prism when it is placed in the air medium to that of the refractive index of the prism when it is in refractive